So hello everyone, and today we'll see one of the very basic problem from Geeks for Geeks. It says check if all bits set, and the name itself implies that we are given a number n, and we need to check whether every bit in the binary representation of the given number is set or not. Return true if yes, otherwise false. We are also provided with an example 7 which has 111 as a binary annotation, and we return true because every bit is 1. That is not possible with 8 because not every bit is 1, and obviously 0 is considered as false. Cool. There are several ways, but we are going to do it most optimally, which is O of 1 time complexity. Now, how can you solve this in a naive way? Obviously, we are solving it O of 1, but before that, we'll see brute force. In a brute force approach, you can go ahead and check each of the bits, take and when you extract each of the bits, compare and you go forward, which would take O of n, where n is the bits, number of bits. Ideally it's 32 bits, or somewhere in some cases it's 64 bits. I know it is still O of 1, but again the bit size is still dependent of O of n. Now what is O of 1 solution? I'll take back one example which was given 111. Now you see everything is 1, and that's what we wanted to find. Expected. That is what expected, that is what we wanted to find. Now I want you to imagine one thing, that if I add even a 1 to this, everything will be like 1000, or let's take another number which is this. It will be like 100000. So it would be like this something. And you can see the pattern over here. I am having this, which is n, and I have this which is n plus 1. What I can do, I can just take an AND operation of this both, and I can get the value as 0 entirely. The moment I get that, I understand that hey, it is 1 entirely. The cases where this is not true, whereas like this, and I'm adding 1, if you're providing me with this number which is 5, which is 10 I guess, n, and I'm taking n plus 1 as this, and if I'm adding this, then it gives me an output of like 1 0 1 0. So this is obviously not true, and here we return false. Okay, I'll just take false. And yeah, that is how we are going to do this. So the code is already over here, which I'm taking n, ending with n plus 1. If it is 0, then it is true, else it is false. Obviously we have a base case where n is 0, because they mentioned 0 is false and we don't want anything over there. And this is an exception where n plus 1 is 1 and n is 0, and anything ending with 0 is 0 obviously. So we need to take care of 0. So handled it separately. So let me try to submit this one. And yeah, it passed all the test cases, and this was fairly simple. This was one of the bits problem. If you wanted to see more such kind of bit related questions or operations, click the video on your right, and I will see you in the next one.